Hello, welcome back to my grade 11 math review number 2, that is Parabola number 1. Let's look at these important concepts in algebra before we go into the parabola. They are exponents, directed numbers and quadratic expressions. If you understand these concepts clearly, then you will not have difficulties later. Let's look at the exponent rules. If you multiply this letter A 5 times like this, you end up with a to the power 5. I am using this star for the multiplication sign. And if you multiply a to the power 3 by a to the power 4, what do you get? You have to simply add the two indices. The answer is a to the power 7. How does it happen? A to the power 3 means 3 a's together multiplied by a to the power 4, another 4 a's. So how many a's we have now? 7 a's. So you simply add the two indices. When you divide a5 by a3, what happens? On the top you have 5 a's, on the bottom you have 3 a's. So 3 of them will cancel out, you end up with a to the power 2. So simply what you have to do is you subtract 3 from 5. 5 minus 3, 2. Now see the difference between this operation and this one. Here you can see 2 a's. Here you can see only 1 a. A to the power 3 to the power 4. That means we have to write a to the power 3 4 times. So altogether a3, 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 a3. So you can see that there are 12 a's. So your answer will be simply multiplying the two indices. So look at the two different forms. Here you multiply the indices, here you add the indices. You can see 2 a's here, only 1 a here. Now let's quickly look at some directed numbers. 2 multiplied by 3 is 6. So these brackets assume that you are multiplying. And now if you multiply minus 2 by minus 3, what do you get? When both are minus, answer is plus. Minus 2 multiplied by plus 3, minus 6. 2 multiplied by minus 3, minus 6. So the concept is, if one of these numbers is negative, the answer is negative. Now we are going to see the addition. We know that 5 plus 9 is 14. This one, take a look at this one. Minus 5 plus 9. Always the sign of a number is the sign in front of that number, not the sign after that. I know that some people have a confusion. So minus 5 plus 9, when one of these two numbers are negative, the answer will be the difference between the numerical values of these. That means 9 minus 5 is 4. And the sign of this number is the sign of the bigger number numerically. So the bigger number is positive, therefore is positive. This one is negative, 1 is positive. When there's no sign in front, we assume that is plus. So the difference is again 4. And the bigger number has negative sign, so the answer is minus. When both are minus, we simply add them together and the sign is always negative. When I was in grade 8 or 9, I also had a difficulty in these directed numbers. I saw a book, very old book, written by somebody called J. Jayasuriya. He explained these additions or simplification as a profit-loss concept. That means if a number is plus, it's a profit. If a number is negative, it's a loss. Assume that you are going somewhere. You find $5 on the road. And then After that you lose $9. So what is the net effect? You have still lost $4. You lost $5, you lost $9, so you lost $14. You lost $5, but on the way you found another $9. So as a whole you have gained $4. Now we are going to put another x in front of that, behind that. 5 plus 9 is 14. Now we have 5x, that means you multiply your 5 by x, 5x, 9x. So same concept, but your answer will have another x. Same is true for this one. It could be even x squared, x times x. So same answer minus 4, but x squared, x squared, x squared. Now we are going to see quadratic story, quadratic functions. Before we saw linear functions like y equals x plus 1. When we have x squared terms, we call such expressions quadratic expression. When it is like y equals something, it's a quadratic function. X means x multiplied by x. Now let's make a chart to understand this one, xy chart. When x is 0, 0 squared is 0, so the answer is 1. When x is 1, 1 squared is 1, 1 plus 1, 2. So y is 2. When x is 2, 2 times 2 is 4, 4 plus 1, 5. And let's look at the minus 1. Minus 1. X is minus 1. Minus 1 times minus 1 is plus 1. So 1 plus 1, 2. Same for these. So we can draw a graph now for that function, quadratic function. You can see when x is 0, y value is 1. When x is 1, y value is 2. When x is 2, y value is 5, and so on. When x is minus 1, y value is 2, and so on. So we have a quadratic function or a parabola. Part B under this section is expanding perfect square, completing the square, and factoring. Let's look at this one. 2 plus 4 multiplied by 5 plus 7. We can simplify the things inside the bracket. It becomes 6. 5 plus 7, 12. So 6 times 12 is 72. You can do that in a different way. You will know why. First we multiply 2 and 5 together. You get 10. And then 2 and 7 plus, then we go to this number, the bottom, 4 times 5, then 4 times 7, and then add all these together, and you 2 times 5 is 10 and 14 and so on, and you end up with the same answer as before. When you have to multiply two binomial expressions like this, you do the same thing. First, x times x, x squared. X times 3, 3x. Then at the bottom, 2x, 2 times 3, 6. And these two are like terms, so we can add them. Become 5x. Same is here. X squared minus 3x, either minus sign in front of 3. And 2x plus 2 times minus 3, minus 6. So we know that minus 3 plus 2x is now minus x. Let's look at perfect squares now. We know that 16 is a perfect square because 16 is equal to 4 times 4. In other words, 4 times 4 is equal to 16. 16 is called a perfect square because you can get 16 by multiplying two numbers, the same number two times. If you look at x plus 5 multiplied by x plus 5, what happens? You get x squared, 5x, and 25. This is the answer. So when you multiply the same binomial expression with the same one, you get a special situation. You can notice something. If you divide this number by 2, you get 5. 5 squared is 25. Let's look at another example with a minus sign. X squared minus 9x plus 81. Again, the only difference between these two is here you have a minus sign when you are multiplying two expressions with the minus here. Again, if you divide 18 by 2, you get 9. 9 squared is 81. See this sign, plus, but only here minus when these two are minus. Now we are going to look at the concept called completing the square, which will be used in your parabola lessons. Now, when we complete the square for this expression, we end up with this one. It is called the vertex form of a parabola. Now let's see step by step how we are doing it. First, you keep your constant a little bit far away from this one, plus 35 here. And then divide this number by 2. It's 5. 5 squared is 25. So add 25 and subtract 25. That's the next step. So when you are adding and subtracting, you are not doing any change. Next step, you underline the first three terms. Move this minus 25 a little bit towards this side. Now at this moment we know that this is a perfect square. We can replace this underlined section by x plus 5 squared. And now we simply add these two numbers together. Minus 25 plus 35. You lost $25 but you gained $35, so the answer is plus 10. So it's called the vertex form of your parabola. We'll see more details later. The last section in this section is factoring. What are the factors of 6? 6 can be expressed as 1 times 6 or 2 times 3. So 1, 6, 2, 3, they are called factors of 6. We know that if we multiply x plus 2 by x plus 3, we get x squared, 3x, 2x, and 6. This one. In other words, the factors of this expression is this one and this one. X plus 2 and x plus 3. Just like this one. So, this is how we used to factor an expression. Put the brackets like this, put the x and x. Now we have to look for these numbers. This last number we write in the right hand side and think about their factors, 2 and 3, 1 and 6. And check whether you are getting your middle term by adding or subtracting these numbers. 3 minus 2, 1. So it's not 1. 2x plus 3x, 5x. So it works. Therefore you write down 2 and 3 here. 2, 3. And put the correct sign so that you end up with the correct plus 5x. Before we end up, let's look at some common factors and difference of squares. How to factorize this one? You can see that 2 is common to both terms, so we take the 2 out and check whether it is going to be true. 2x plus 2 times 2, 4, so it works. This is about the difference of squares. If we multiply x minus 6 with x plus 6, what do we end up? X squared plus 6x minus 6x and minus 36. See, they cancel out. So when you have a situation like this, you end up with x squared minus 36. Let's look at another example. Same thing. You end up with x squared minus 49. So we can see that when we have a difference of squares like that, 36 means 6 squared, 49, 7 squared. Our factors are x minus 7 and x plus 7. Then we know that for this one the factors are x minus 8 and x plus 8. Another example. 225 is 15 squared, so the answer is this one. Bit hard one, the last one. Now 50 is not a perfect square, therefore we have to take the 2 out first. Then we end up with a squared minus 25. So we have already factorized partly. Then 25 is 5 squared, some mistake. Therefore, when you factorize this part, you end up with a minus y, a plus y. So that's your final answer. So this expression has 3 factors, 2, a minus y and a plus y. Thank you for watching, and let's see you in my review number 3, where more details about parabola will be discussed. Thank you.